Hi dear students of plus 2 medical, non-medical, respected teachers and dear friends. In this video I am going to discuss about a very powerful device known as a nuclear reactor. So device which is used for constructive purpose. It produces huge amount of energy, and that huge amount of energy is used only for constructive purpose. So such a device is called nuclear reactor. The principle of nuclear reactor, it is based upon the principle of controlled nuclear chain reaction, fission reaction, but it is controlled, because if it is uncontrolled, it becomes explosive. It becomes principle of atom bomb. So controlled nuclear chain reaction is the principle of nuclear reactor. Construction. So it consists of a cabin which is about, has walls about 2 to 2.5 meter, concrete walls having thickness 2 to 2.5 meter. In this concrete chamber there is a fission chamber which consists of fuel rods. These are shown by dark. Then these fuel rods contain uranium 233, 235, Pu 239, etc. So it acts as a fuel rods, because this uranium 233 or 235, when bombarded with one electron, it splits into two lighter nuclei, 3 neutrons are produced, and huge amount of energy is released. This is nuclear fission. Then there are moderators shown by these dots. These moderators are very important. These moderators are usually like heavy water, graphite, deuterium, paraffin, वगैरह वगैरह. The purpose of these moderators is to slow down the fast moving electrons produced during nuclear reaction, splitting of uranium 235, nuclear fuel, to slow down fast moving neutrons, so that slow neutrons can further cause nuclear fission. Then we have control rods, which are made up of, these control rods made up of boron or cadmium. The purpose of these control rods is to control the nuclear reaction. It is used to absorb slow neutrons, which are slowed down by the moderators. And by controlling, we can control the flow of slow neutrons further. So these slow neutrons further cause, remaining slow neutrons, they can cause further nuclear fission. So by controlling from these cadmium rods, control rods, so we can, by inserting or by taking out, we can control the speed of the reaction. Then we have a coolant. At low temperature we can use heavy water, but at high temperature the coolant used is liquid sodium. So here is liquid sodium, which absorbs heat produced during nuclear fission of uranium atoms. So this huge amount of energy produced is transferred to the water chamber like this, and here is a pump to pump out the coolant back to the fission chamber. So this is known as fission chamber. So as a result, this water gets heated. So exchange of heat takes place. So coolant exchange the heat energy to the water. So from this water, superheated steam is produced, which goes through this tube and which drive the turbine here. This is a steam turbine and which is coupled with the electric generator to produce electricity. So this turbine, this steam energy drives the turbine. So this mechanical energy then is being converted into electrical energy. So it's the purpose of electric generation. Then this used steam comes back to the condenser. It gets cooled. So it comes cold water, comes out this, and this process continues. This water is again given to this, and this process continues. So then there is shielding. I already told this whole apparatus is shielded in a very thick wall of the order of thickness 2 to 2.5 meter concrete wall to avoid the leakage of radiation which are harmful to life. So this is the basic construction and working I have explained. So I again explain what happens. So slow neutrons slow down by the moderators. Slow neutron strikes the uranium-235 to fission products are produced like barium, krypton. 3 neutrons are produced. These are the fast moving neutrons. Then these are again slowed down by the moderator. Out of 3 to make it steady, sustained direction, 2 are absorbed by the cadmium rods and 1 slow neutron further causes nuclear fission. Again 3 neutrons are produced fast moving which are further slowed down by the moderator. Some are absorbed by the cadmium rods and this process continues. So as a result, we have a sustained nuclear chain reaction. So again I repeat, it consists of control rods. By controlling these control rods, position of these control rods, we can control the reaction. There is a coolant, liquid sodium. These are the nuclear fuels. Then these are the moderators to slow down like neutrons, fast moving neutrons. And this is the process of production of steam, superheated steam, which drives the turbine, and this process is known as working of nuclear reactor. So nuclear reactor has so many applications. Nuclear reactors are used to generate electric power. Nuclear reactors are also used to produce radioisotopes which are used in medicine, agriculture, industry. Nuclear reactors are also used to propel ships, submarines, aircrafts, and nuclear reactors are also used for treatment of cancer and nuclear research. So these fast moving neutrons is used to treat cancer patients. So there are so many uses, and these reactors are used for constructive purpose. So for example, the famous nuclear reactors in India are Apsara, Zarlina, Dhruva, and CIR, Canada India reactor. So these are the famous nuclear reactors which are working in India. So this is all about nuclear reactor, and till next video, stay tuned, good luck, all the best, be happy.